Okay, in this video, we're going to start solving some exponential equations. Now, let me go ahead and warn you that not every exponential equation can you solve the way that we're going to solve in this video. These are only going to be ones with common bases. So here we go. Use the properties of exponents to simplify each side of the equation. Step 1. Rewrite the equation so that both sides have the same base. Now, what can we do if we can't write them as the same base? That's what's going to be later on in the chapter. Then we're going to drop the bases, and we're going to set the exponents equal to each other, and that's it. So number 1, zoom in. This one, everything's been combined. You don't have to use your properties of exponents, and you already have the same basis. 2 to the x plus 1 power equals 2 to the 9th. Now think about it. If I say 2 to the x is equal to 2 to the 5th, what could I put in the place of x so that makes this a true statement? Well, 5. So if the bases are the same, you can actually forget about the bases and set the exponents equal to each other. And that's all you're doing here. 2 to this power equals 2 to this power. So therefore the powers, the only way that this can be true is if the powers are the same. Solve that and you get x is 8 and you're done. Plug that 8 in, you get 2 to the 9th equals 2 to the 9th. Number 2. 5 to a power equals 5 to a power. The only way that this can be true is if the powers are equal to each other. So set the powers equal. Move the n by subtracting, leaves you with 3n. Move the plus 5 by minusing 5. That'll be negative 12. Divide by 3, it gives you n is negative 4. Number 3. Now this one we are going to have to use our rules of exponents. You have 3 to a power times 3 to a power. You combine these power by adding exponents. So k plus 2, let's combine our like terms, will be 2k plus 2 equals 3 to the 5k minus 1. Now you can set the exponents equal to each other. 2k plus 2 would have to equal 5k minus 1. Move your k's to the same side. We'll move to 2k's. You now have 3k's. Move the minus 1 by adding 1. 3k is 3, so k would have to equal 1. Number 4. Again, rules of exponents. 10 to a power times 10 to a power. Add those exponents gives you 10 to the 5th power. The other side, same thing. 10 to a power times 10 to the power. Let's add our exponents. 2v and v gives you 3v plus 4 minus 11 gives you minus 7. 10 to a power equals 10 to the power. So therefore, the only way this is true is if the powers are the same. Add 7 divided by 3, you get v is 4. Number 5. These types, these do not have common bases. So what we're going to have to do, we're going to have to somehow rewrite these to where the bases are the same. So on the left side of your equation, you have 6 to a power. So we're going to rewrite the right side as 6 to the 2nd power. 6 times 6 is 36. Now you have 6 to a power equals 6 to a power. Now you can set the powers equal. Add 10 gives you 2x is 12. Divide by 2 gives you x is 6. Number 6. Same thing, 2 to the p minus 7. Well, on the right side, you have 8. That is 2 times 2 times 2. That's 2 to the 3rd power. Now that your bases are the same, you can say p minus 7 has to be 3. Add 7 gives you p must be 10. Number 7. 7 to the 4x plus 11. The right side you can rewrite. That's 7 to the negative 1 power. 7 to the first on bottom, bring it to the top. That's 7 to the negative 1. Set the powers equal. Subtract 11 gives you 4x is negative 12. Divide by 4 gives you x is negative 3. Number 8. Same thing, 2 to a power, 2 to the 2m minus 9. 32 is 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now that the bases are the same, set the exponents equal. Minus 9 by adding 9, that's 14 is 2m, so m must be 7. Number 9. 27, now this one's a little bit different because you have 27 to a power, then you have 3 to a power. We can leave the 3 to a power, but we need to create a 3 here. 27 is the same thing as 3 times 3 times 3, that's 3 to the 3rd. That's being raised to this power. Now your power rule says if you ever have a power raised to another power, you have to multiply them. So we can now write this as 3 to the 6x plus 18 power equals 3 to the 2x power. Set the exponents equal. 6x plus 18 has to equal 2x. Move the 6x by subtracting 6x gives you 18 is equal to negative 4x. So divide by negative 4 gives you x is negative 4.5. Next problem, number 10. 4 to the y plus 2 is equal to, and 16 we can write as 4 to the second power, and that's being raised to the y minus 3 power. So now power to power, we are going to have to multiply those together. You have 4 to the y plus 2 equals 4 to the 2y minus 6. Make sure you distribute. Now you can set the powers equal. Y plus 2 is 2y minus 6. Move the y by subtracting. You have 1y. Move the minus 6 by adding, and it gives you y is equal to 8. Number 11. Now this one, it's going to be a little bit of a problem because you can't write 125 as 25 to a power. So what we're going to do, we're going to try to change them both. 125 is 5 times 5 times 5. That's 5 to the third power if you did your prime factorization. 25 is 5 to the second. Now you have the same basis. And you can say 5 to the 3y is equal to 5 to the second. 3y would have to equal 2. When you divide by 3, 2 divided by 3 is 2/3. And you're done. Number 12, same thing here. We're going to try to write these both to the same power. This is 4 times 4, but this is not a power of 4. So we're going to have to go down further. We're going to write 16 as 2 to the fourth power. We're going to write 8 as 2 to the third power. Both of these numbers are base 2 numbers, so we can do this. Power to power, multiply them, gives you 12x. Power to power, multiply, gives you 3x plus 6. You have to distribute. The powers now are set equal to each other. Subtract 3x gives you 9x is equal to 6. Divide by 9 and you reduce it, that gives you x is equal to 2/3. Next one, number 13. 4 and 8 are both base 2 numbers, so 4 we can write as 2 to the second. 8 we can write as 2 to the third. To raise those powers to the other powers, you're going to multiply. 2 to the 6x is equal to 2 to the 3x minus 3. Now that the bases are the same, set your exponents equal to each other. Subtract your 3x and it gives you 3x is negative 3. Divide by 3 gives you x is negative 1. Number 14. 81 is a base 3 number. It is 3 to the fourth power. So we have 3 to the fourth raised to the 2x plus 5. 1/3, that's 3 to the 1 on bottom. When you bring it to the top, that's 3 to the negative 1 power. And that's being raised to the 2x power. Powers to power, let's multiply. This is 3 to this 8x plus 20 equals 3 to the negative 2x. Now set your exponents equal. 8x plus 20 is equal to negative 2x. Let's move our 8x, gives you 20 is negative 10x. Divide by negative 10 and you get x is negative 2. Number 15. 8 and 32 are both base 2 numbers. 8 is 2 to the third. And that's a minus 1. And 32 is 2 to the fifth power. And that's to the 2a plus 1 power. Powers to power, let's multiply. 3 times 2a minus 1 will be 6a minus 3. And 2 to the fifth, 5 times 2a plus 1 will be 10a plus 5. Set your powers equal to each other. Gives you 6a minus 3 is equal to 10a plus 5. Move your a's to the same side. Let's subtract 6a's. It leaves you with 4a's. Subtract 5 leaves you with negative 8. Divide by 4 gives you a is negative 2. Next problem. 27 and 243. I know that 27 is 3 to the third, so I assume that 243 can be written as a power of 3, and it's actually 3 to the fifth when you multiply it out. Same thing, powers to powers. Let's change them both by multiplying. This would be a 6x, and this would be 3 to the 5x minus 10. Make sure you distribute there. Set the powers equal to each other. 6x equals 5x minus 10. When you move 5x, it gives you 1x is negative 10, and that's it. Number 17. We do have to use our rules of exponents here. 64, if you would like to, you can go ahead and write as 4 to the third. However, on the right side, you have multiplication, so you have to add your exponents. So that'd be 4 to the 1 plus 4x, or you could put 4x plus 1 either way. Now that the bases are the same, your exponents you can set equal to each other. Subtract the 1, you get 2 is equal to 4x. Divide by the 4, and that gives you x is equal to 2 divided by 4 can be reduced to a half. Number 18. Rules of exponents again on the left side. We're going to add our exponents. So we're again going to add our exponents. So it's going to be 9 to the 2x plus 4 plus 2x would be 4x plus 4 equals, this 81 on bottom is 9 to the second power. Bring it to the top and it becomes a 9 to the negative 2 power. Now you can set your exponents equal. 4x plus 4 is equal to negative 2. Move the plus 4 by subtracting, gives you 4x is negative 6. We're going to divide by 4, and that gives me x is negative 3 halves. Number 19. All of these are base 7s. This is 7 to the first. Bring it to the top. It becomes 7 to the negative 1. This is 7 to the second, and it's being raised to the x minus 5 power, times 7 to the x minus 9 power. So you now have 7 to the negative 1 equals power to power. Let's go ahead and multiply these. 7 to the 2x minus 10 times 7 to the x minus 9. You can now multiply these by adding your exponents. So combine like terms, that'd be 7 to the 3x, and then the negative 10 and negative 9 would be negative 19. We now set our exponents equal. Negative 1 is equal to 3x minus 19. Move minus 19 by adding gives you 18 is 3x. Divide by 3 gives you x must be 6. Number 20. You have 4 to the 2x. Let's actually write everything as a power of 4. The 16 is 4 to the second. When you bring it to the top, it becomes 4 to the negative 2. And then you have a 4 to the 6x plus 18 power. To multiply with the like bases, you add your exponents. That'd be 4 to the 2x plus negative 2, or 4 to the 2x minus 2, equals 4 to the 6x plus 18. Set your exponents equal. 2x minus 2 equals 6x plus 18. Move the 2x by subtracting. You now have 4x. Move plus 18 by subtracting. You now have negative 20. Divide by 4, and you now have x is negative 5.